1.2 Linear equations and rational equation preparation. So we're going to go over some basics and then it'll get more complicated. So first thing we're going to do is we're going to write in prime factored form 35 and 24. So first thing we need to do is we need to know what prime numbers are. Prime numbers are numbers divisible by themselves and 1 and only that, right? So 2 is a prime number because I can divide 2 by 2 and I can divide 2 by 1 evenly. 3 is also prime because I can divide 3 by 3, right? And I can divide 3 by 1 evenly. 4 is not prime because I can divide 4 by 2, which will give me a 2. So this is a composite number, so 4 is not listed. And that's how they came up with all the numbers on this list, right? So 4 is not listed, 6 isn't listed because I can divide 6 by 2 and 3, 8 is not listed because I can divide 8 by 2 and 4, and so on and so forth, right? So we know what the prime numbers are. Now, whenever we are trying to find the prime factorization of a number, you can either do like the little branching tree one. I like to do a little more compact form of that. And what I would do is I would first look at the first prime number that I can evenly divide into 35. So if I say 35 divided by 2, I get 17.5. So that is not going to work. So I move on to 3. 35 divided by 3 gives you an odd fraction. It's not really going to work. 35 divided by 5, yes, that does work. It gives you a 7. Now, you try to divide 7 by 5, it's not going to work. You move on to the next prime number, which is a 7. Then you say 7 divided by 7 is 1. So the prime factorization of 35 is 5 times 7. So you would say 35 equals 5 times 7. Okay, let's go over here and try the other one. 24. So we try the first one again. First prime number is 2. So we try to divide 2 into 24, and we get a 12. We say 12 divided by 2 gives me a 6. 6 divided by 2 gives me a 3. 3 divided by 2 gives me 1.5. That's not going to work. You move on to the next prime number, which is a 3. 3 divided by 3, 1. So that gives you a prime factorization of 24 of 2 times 2 times 2 times 3. And that is the same as saying 2 to the third power, right? Because you multiply 2 by itself 3 times. Times 3. Okay, so you have the prime factorization. All right, let's try to reduce some fractions. Whenever you're dealing with fractions, the correct answer should always be simplified as a fraction. And by simplified, we mean that the largest number that you can divide into both the numerator, the number on top, the denominator, the number on the bottom, is by 1. Okay, then you know it is simplified. So, for instance, I can divide a 10 and a 15 by 5. That means this is not simplified. Okay, so there's a couple of ways of doing this. One is you can use the GCF, which is the greatest common factor, or the largest number that I can divide both into a 10 and a 15. So I can divide both of these by 5. So 5 is the GCF. So what I'm going to do in this case is I'm simply going to divide both the numerator and the denominator by 5, and that would give me a 2 over a 3. Now, since the largest number that I can divide both into a 2 and a 3 is a 1, that means this is simplified. So the simplification of 10/15 is 2/3. Now, we could also do it on this one, the greatest common factor of a 15 and a 45 is a 15. So we could divide both of these by 15. That's the greatest common factor. And that would give me, again, a 15 divided by 15 is a 1, and 45 divided by 15 is a 3, so you end up with 1/3. And since the largest thing that I can divide into a 1 and a 3 is a 1, we know we're done. Okay, let's say we wanted to find the greatest common factor of 150 and 200. So you can kind of eliminate these zeros if you want. And then what you can do is you can divide both of these by 5. And that would give you a 3 over 4. And since the largest thing I can divide into a 3 and a 4 is a 1, so you know that is simplified, so you're done with that one. Now, you could chip away at these. For instance, let's say you didn't know what the greatest common factor of 150 and 200 was, but you did know that a common factor was in fact a 10. Okay, and this is kind of explicitly what I was doing up there. So now we say, well, that would give me a 15 over 20, and then you could finish this off by dividing them both by a 5, which is essentially what I did above, but I'm actually just writing it out now. So the point being is, let's say you're dealing with really large numbers and you can't find the greatest common factor, but you can't find a common factor. Well, you can chip away at it and then just break it up into multiple steps. Sometimes when the numbers get really large, that's an option, right? Or maybe you want to do it with prime factorization, so you say 15 is actually 3 times 5 over 45, which is really 3 times 3 times 5. And then you would just cancel out the like terms. And when they cancel out, they actually turn into ones. So you're actually going to have a 1 times 1 over 1 times, 3 times 1, which gives me 1 over 3, which gives you the same answer as that, right? The same thing. Okay, so you can do prime factorization. You can break up simplification with a greatest common factor. You can break it up into multiple steps like I did over here. So there's a couple of ways you can do that. All right, let's try some more. So let's say we want to multiply fractions. So whenever we're multiplying fractions, what we want to do is we want to multiply straight across, numerator times numerator and denominator times denominator. If you're multiplying more than 2 fractions, you're still going to multiply straight across, numerator times numerator by however many numerators there are, and denominator times denominator by however many denominators there are. So this is really, I'm going to write this step out, but you don't have to. 3 times 4 over 8 times 9. And that would give you 12 over 72. Now at that point, we could simplify it using the GCF. So the greatest common factor in this case would simply be, is a 12. So 12 divided by 12 is a 1, and 72 divided by 12 would be a 6. So you end up with 1/6. A little more advanced way of doing this is you cancel out what you can. So 3 divided by 8, nothing will cancel out. 3 over 9. You can actually divide both the 3 and the 9 by 3, and that would give me a 1 over a 3. And we say 4 over 8. Well, you can divide both 4 and 8 by 4. 4 divided by 4 is 1, and 8 divided by 4 is a 2. So what you would end up with in this case is a 1 times 1 over a 2 times 3, and that would give me 1 over 6, which, if you notice, is the same thing. Now, for simple fractions, it's probably better just to do it the first way. As they get more and more complex, you want to cancel things out before you multiply because you're going to be dealing with a great deal of variables, sometimes even parentheses. Sometimes the numbers are going to be really large, and you're going to have even multiple fractions. So if you can cancel things out before you multiply, it will probably make your life a little easier. So easy ones probably do it the first way. More difficult ones probably do it the second way. Okay, so let's try this one. So let's try simplifying before we multiply, right? 7 over 3, 7 over 4, nothing will cancel. 5 over 3, 5 over 4, nothing will cancel. So we just multiply straight across, and we end up with a 3 times 5, which is a 35, and a 3 times 4, which is a 12. And that's all you get. Now, notice that this is an improper fraction, meaning that the numerator is larger than the denominator. Now, sometimes you write this as a whole number, and I can show you how to do that later, but oftentimes underneath where you enter it into My Math Lab, it will actually tell you how they want the answer, either as an improper fraction. It'll tell you if they want it as a mixed number. They'll tell you if they want it as a proper fraction, or a mixed number. So just be aware that you need to enter it in the form that they're asking for. And even if you have technically the correct answer, you may not get credit if you don't enter it in the form they're asking for. So just be careful about that. Okay, let's say you're multiplying a whole number by a fraction. Well, whole numbers are understood to be over a 1. So 5 over 1 times 7 over 10, right? Now I can divide both the 5 and the 10 by 5. 5 divided by 5 is a 1, and 10 divided by 5 is a 2. And that would give me 1 times 7 over 1 times 2, which gives me 7 over 2. Now whenever you're dividing a fraction, your first step in dividing a fraction is going to be to turn the division into multiplication. So you keep the first fraction, turn the division into multiplication, and then you multiply by 5/8. Okay, now we try to cancel things out. 3 and 4, the largest thing I can divide into both of those is 1. 3 and 8, largest thing I can divide into both of those is 1. 5 over 4, largest thing I can divide into both of those is a 1. 5 over 8, the largest thing I can divide into those is 1. So you're not going to simplify anything. So 3 times 5 is a 15, and 4 times 8 is a 32. So let's try the next one. First step when dividing fractions is you keep the first fraction, you change the division into multiplication, and you multiply by the reciprocal, or you flip the second one, right? So we're going to flip the 5 and the 8, and that becomes 8 over 5. Okay, so 3 over 4, 3 over 5, no. 8 over 4, yes. Because I can divide both the 8 and the 4 by 4. 8 divided by 4 is a 2. 4 divided by 4 is a 1. Then we multiply whatever's left over, right? So 3 times 2, and 1 times 5, and that would give me 6/5. Okay, now you might be tempted to try to cancel things out before you switch to multiplication. You can't do that. So over here, an easy mistake would be to cancel the 8 and the 4 out before you turn the division into multiplication, but you can't do that. So don't do the cancellation until it's multiplication. If you do it when it's still division, you're going to mess it up. Okay, so again, make sure it's multiplication before you cancel anything out. Okay, so let's try the next one. So again, if you see a whole number and you're either multiplying or dividing fractions, it's understood to be over a 1. So first step on this one is we are going to keep the first fraction of 5/8. We're going to turn the division into multiplication, and we're going to multiply by 1 over 10. Now we see if we can cancel anything out. 5 over 8, no. 5 over 10, yes, because we can divide both 5 and 10 by 1. 5 divided by 5 is 1. 10 divided by 5 is 2. We multiply the leftovers, 1 times 1, over 8 times 2. And what we'll end up with is 1 over 16. And there you go. Okay, let's try the next one. So we have 5 over 3 multiplied by 5 over 7. And what you end up with is 5 over 5. Well, nothing's going to cancel out. You can always check, right? 5 over 3, 5 over 7, 5 over 3, 5 over 7, no. Okay, so 5 times 5 is 25. And 3 times 7 is 21. And that's it. Now, if you're dealing with complex fractions, you really simplify them as if they're division. So 3/4 divided, or 3/4 over 8/5 is really the same as 3/4 divided by 8/5. So the way you deal with the division of the fractions is you take the first fraction, 3/4, you leave it, you multiply by the reciprocal of the second one, 8/5, you flip it to 5/8. And then you see if anything will cancel out. 3 over 4, 3 over 8, no. 5 over 4, 5 over 8, no. So you multiply through. 3 times 5 is 15. 4 times 8 is 32, and then you're done. Now, when you do enough of these problems, it's going to be, you can kind of skip steps. You can just look at this and, skip as many steps as you want. Write as many steps as necessary to get the correct answer. At the beginning, you probably write all the steps, and the more of the steps you write and the more often you do it, the more you're going to internalize it, and you'll be able to do more and more of the math mentally. So at the beginning, we're going to write a lot of steps. Later on, you're going to start skipping a few steps, and eventually you'll be able to do quite a few of these things, mentally, be able to do all the math. What I will say is if you're skipping a bunch of steps and you're making a bunch of mistakes, it would behoove you to write more steps down. It's easier, and you don't have to keep track as much within your mind at once if you write it down. Writing the steps makes the math easier, not more difficult, even though it can be tedious and it can take a little more time. Then later on, whenever you get really good at it, you can start skipping a few steps. That's okay. So let's see, we have 3/4, rewriting 3/4 over 5/8 by 3/4 divided by 5/8, which is the same as 3/4 multiplied by 8/5. See what happens here. We have the 8 and the 4 will cancel out. 8 divided by 4 is 2. 4 divided by 4 is 1. And we end up with 3 multiplied by 2 over 1 multiplied by 5, which gives me... Sorry, I wrote down the sixth answer. So it's 3 multiplied by 2, which gives me a 6 over a 5. Okay, now, so we have 5/8 over 10. 5/8 divided by 10, right? And that's understood to be over a 1. And we could say 5/8 multiplied by 1 over 10. So we have 5 over 8, no. 5 over 10, yes, because 5 divided by 5 is 1. And 10 divided by 5 is 2. So what you end up with is 1 times 1 over 8 times 2, which gives me 1 over 16. If you notice these are the same problems as the previous ones, but written differently, you are correct. That is not an accident. Just wanted to show you how different problems can look, but they actually work the same. They are the same concept. All right, so we have 5 over 3 divided by 7 over 5, which is the same as 5 over 3 multiplied by 5 over 7. And since nothing will cancel out, we'll end up with 5 times 5 is 25, and 3 times 7 is 21.